All right, welcome back, grade 11s. We're going to be starting week 2 with a lot of new material. So it's super important that you watch these videos and follow along with the lessons that are made available to you on D2L because this is all brand new material that is extremely important before you enter grade 12. Which is why we're taking the time to go over it now. So we're going to cover this week 5.2, 5.3, and 5.4. They all go together. It's pretty much all one big long lesson, but I am going to separate it into those chunks. So again, copy or print out the lessons from D2L and pause as much as you need to on the video in order to copy or fill in or work ahead, and then check with me as I take it up on the video. Please do the homework that is assigned. That will help prepare you and solidify your understanding for this week as we move into next week, which is the final week of this chapter. And you can expect a quiz on 5.2, 5.3, 5.4 sometime next week, probably towards the beginning. So it's super important that you get through these lessons, you do the practice, and then of course you ask me if you come across any questions you don't understand. So we're going to start right now with the first lesson, which is where do we get exact values from when we're dealing with trigonometry so that we're not reliant on a calculator for our answers. And remember that trigonometry was done for the longest time, right, before the invention of a calculator. So mathematicians were able to determine exact values for many of the trig amounts, so 30 degrees, 60 degrees, 45 degrees, 120 degrees, for sine, cos, and tan. So what you're going to do is you're going to learn how to generate those same exact answers. So you will not need a calculator at all. In fact, if you're touching a calculator, you're probably doing something wrong. So in order to get these special values, what we need to do is we need to know these two special triangles. So the first triangle is the 45-degree triangle. The second triangle is for the 30-60 degree answers. And you don't need to memorize these triangles. If you're like me, you just memorize or learn how to generate them. And you can always generate them and do them from scratch on the top of every quiz or test. And therefore, there's no memorization required. So in this first case, we have a 90-degree isosceles triangle. So there's the 90 degrees, and it's isosceles, which means this side and that side match. We can put any number we want on these two equal sides, but the lowest value that makes the most sense without having to work with decimals is 1. And that means, since we know it's isosceles, and we know that the angle sum of a triangle is 180 degrees, this angle and this angle match, right, because it's isosceles, and they must be the leftover to the remaining 90 degrees, which means this corner is 45 degrees, as is this corner. So with both of them being 45 degrees, now we've filled in all the angles. All we're missing is the hypotenuse, and you already know how to find the hypotenuse. So 1 plus 1 equals c squared, 2 equals c squared, but we don't want c squared, so we square root. So this is root 2. Notice it's left as root 2. It's not called 1.4 blah, 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 blah. So these are the exact values for your 45-degree triangle, which means now you can tell me the exact ratio for sine of 45. Pick a 45-degree corner. Sine is opposite over hypotenuse. It wouldn't have mattered if you use this 45 either. Opposite over hypotenuse. 1 over root 2. Now, some people rationalize. Remember where you times top and bottom by the root 2, which gives you root 2 on top over root 4, which is just a 2. So 1 over root 2 and root 2 over 2 are the same answer. So it won't matter which way to me that you report your answer. They're both the same. But just so you look for and you understand that if you see this as an answer and you wrote it like this, that they mean the same thing. Cos of 45 would be adjacent over hypotenuse. So notice that is 1 over root 2 as well. And tan of 45 is opposite over adjacent, 1 over 1, which is just 1. So tan of 45, the slope of a 45-degree line is 1. Now CSC, cosecant. Remember, cosecant is the reciprocal to sine. So we flip this fraction and we can just call it root 2. So 1 over root 2, just root 2. Same with secant. Secant is the reciprocal to cos, right? C goes with S. So if we flip or reciprocate cos of 45, we just get root 2. And the reciprocal of tan will give us cot. So cot 45 is the reciprocal of 1, which is just 1. So these are our exact values for the 45-degree angle for sine, cos, tan and its reciprocals. So again, how we started, 90-degree triangle, isosceles, I put 1 and 1 here, 45, 45, and we found the hypotenuse as root 2. Now, in the next triangle, we don't start with an isosceles, we actually start with an equilateral. So equilateral means all sides match. What we're going to put here on all the sides is 2. And you're going to see why in a minute, because we're going to cut it in half. Now, because all the sides match, that means all the angles match. And since they all have to add up to 180, 60, 60, and 60 in all the corners. So that's pretty easy, right? Start with an equilateral, 2, 2, 2. All the corners are 60 degrees. Then what we do is we slice the triangle in half, dropping the altitude. Because it was a symmetrical triangle, it bisects the upper angle. So half of 60 goes here and half of 60 goes on the other side. So that's 30 degrees and 30 degrees. Now, so we have 60, we have 30, and of course the altitude makes 90 with the base. The last thing we need to find is the height. How long is this altitude? Because we know that the bottom was 2, and since we cut it in half, this side is worth 1, as is this side. So it's no longer 2 for the whole thing, it's 1 and 1 on each side. So to get h, again, we can use the same formula we did over there. H squared plus 1 squared equals 2 squared, right? So short side squared plus short side squared equals longest side squared. Well, most people would write it like this: 2 squared minus 1 squared, 4 minus 1, and again, we're interested in the square root of that answer. So this is root 3, the height of that triangle. So again, no decimals, keep it as a radical. And just like before, we can now write our answers for 30 and 60 for sine, cos, and tan, realizing that you're only ever using 1/2 of the triangle. So there's the 90, there's the 60, up here's the 30, here was the 1 that used to be a 2 cut in half, here is the 2 that makes up the hypotenuse, and the height was root 3. So we're only going to use one side of this triangle. So sine 30 is opposite over hypotenuse, 1/2. Cos 30, adjacent over hypotenuse, root 3 over 2. Tan 30, opposite over adjacent, 1 over root 3. Sine 60, opposite over hypotenuse, root 3 over 2. Cos 60, adjacent over hypotenuse, 1/2. And tan 60, opposite over adjacent, root 3. So pause right here and fill in the reciprocals for each of those. And then come back and check your answers. Okay, so I hope you did that. Would be 2 over root 3, 2 over root 3, 2, and 1 over root 3 for cot. So all we're doing is reciprocating our answers for the same amount of degrees, but for the reciprocal trig ratio. So remember that if you're given this, you can also always put it back to where it came from, its original. What I'd like you to do now is I want you to look for any patterns. So I want you to reflect now. Explain any patterns you see between 30 and 60. So right now we're on the second page, and it's asking you, explain any patterns you see between 30 and 60. So that's a more important question here. So take a look and see if you see any patterns within this. And the answer is yes. So I hope that you notice that sine 30 and cos 60 match. that cos 30 and sine 60 match. Tan 30, cot 60, tan 60, cot 30. And so there are other patterns, of course, but these are the main ones. So you notice that sine of 30 is worth the same as cos of 60. And the reason is that sine and cos are 90 degrees off of each other. So whatever the answer is to sine of a certain angle, that will be the same value as cos of the complement to that angle. Remember, complementary angles add up to 90 degrees. So the complement to 30 is 60. So that's why they're the same amount. So if this was sine 40, the complement would be 50. So sine and cos would match that way. And it doesn't matter which one is which. So that was one of the patterns that I wanted you to see here, that there are similarities, definitely. So the whole point is, why do we care about this stuff? Well, because it allows us to determine what are called exact values of expressions. So now I can give you longer expressions and ask you to substitute in these exact values, which then you need to use your arithmetic and your algebra to work out. So again, what I want you to do is from memory, up here on the page, somewhere else on your page, generate those two triangles again from memory. Try not to peek. Okay, so the first one was an isosceles 45-degree triangle. 1, 1. And then this was root 2. The other one started as an equilateral, 2, 2, 2, 60, 60, 60. Cut it in half, 1, 1. This is now 30 degrees and root 3. So again, we only use the half of it. The 30s up here and the 60s down here. Now, if you don't remember the root 3 or the root 2, remember that you can always use Pythagorean theorem and always find it again. All right, so determine the exact value. As soon as you see that in a question, you are not to touch a calculator. So equal sign, next line down. Sine 45. Find your 45 degrees. Write in your sine ratio. Opposite over hypotenuse. 1 over root 2. And that is being times with cos of 45, which is adjacent over hypotenuse. 1 over root 2. Then we're going to add to that sine 30. Here's a 30 degrees. Sine is 1 over 2. Opposite over hypotenuse. Sine 60. Root 3 over 2. There you go. So then what happens is we need to multiply these two, and then add them. Top times top over bottom times bottom. 1 over the square root of 4. I'll show all my work. Top times top, root 3. Bottom times bottom, 4. So, oh, sorry, that's root 4. Square root of 4 is 2. So this is really 1/2 plus root 3 over 4. Need a common denominator. So we're going to times top and bottom here by 2 because we're adding now. So we need a common denominator. So this is going to be 2 plus root 3 all over the common denominator of 4. And that's as good as you can get it to. So you don't need to times this by anything. You can't obviously add these together. They are not like terms. Over here, similar question. 1 minus, all right, the sine of 45 degrees. So again, 1 over root 2. Divided by whatever cos of 45 degrees. And 45 and 45, remember, are complementary. So it should be the same answer for cos that it is for sine. Now, this line means divide. So some of you might prefer it if you saw it like this. It might make a little more sense to you. And then remember, when we divide fractions, we change it to multiplying by flipping the second fraction to its reciprocal. Top times top, bottom times bottom, or because we're multiplying, we can cross reduce. So 1 take away 1 is what we get here, which is a big fat 0. Prove the following is true for the given degrees. So we need to prove that sine theta over cos theta equals tan theta if theta is 60 degrees. So sub and 60, sub and 60. So let's do a left side, right side check. So the left side, what is sine 60 divided by cos 60? And the right side would be tan 60. All right, 60 degrees is here. Sine is opposite over hypotenuse, root 3 over 2. I'll use a division symbol. Cos of 60 is 1/2. Flip and multiply gives you root 3. So if you need to see it, root 3 over 2 times 2 over 1. This is root 3. Tan 60, go to the triangle that has 60. Tan is opposite over adjacent, which is just root 3. So therefore, left side equals right side for 60 degrees. So therefore, sine theta over cos theta does in fact equal tan theta for 60 degrees. Okay, second last one. Find theta if 2 root 2 cos theta is worth 2. So why don't we kick this guy out to the other side by dividing him out? So he goes away there because we're trying to isolate for theta in this question. And 2 over 2, we can reduce there. That goes into itself once, into itself once. That's 1 over root 2. So what angle gives us a 1 over root 2 answer? Therefore, cos is, where do you get a 1 and a root 2? Well, there's no root 2 in the 30-60 triangle, so it must be the 45 triangle. And 1 over root 2 comes from 45 degrees. So that must have been the angle that created that statement. Now, if cot alpha could be theta, doesn't really matter. If cot alpha is root 3, determine the exact value of this statement. So cotangent alpha. So cot alpha is root 3. Now, we don't deal with cot, so let's change him back to tan. So if I flip this, that means I flip that one too. So again, where do I see the 1 in the root 3? Well, it doesn't come from the 45-degree triangle. It must come from this guy. And to give me opposite over adjacent as 1 over root 3, opposite over adjacent, it must be the 30-degree corner. So alpha must be the 30 degrees in order to have given me this ratio for tan. So again, 30 degrees, opposite over adjacent, that would have been tan of 30, 1 over root 3. Now that I know that it's 30 degrees, I can now just sub in. So we have sine 30 times cot 30 minus cos squared of 30. All right, so what does this look like? Sine 30, opposite over hypotenuse, 1/2. Cot 30, well, it just gave it to me in the question, which is just a root 3. You can put the 1 at the bottom if you like. And cos of 30 is adjacent over hypotenuse, root 3 over 2. But notice it's squared. So what this means is that the answer to your cos ratio is squared. So cos squared alpha is cos alpha all squared. Top times top, bottom times bottom. So root 3 over 2. Take away root 3 times root 3. I'll show all my work, but most of you will just write a 3 on top. And 2 times 2. So this is root 3 over 2 minus 3/4. Again, since we're subtracting fractions, we need a common denominator, times 2 times 2. So this is 2 root 3 minus 3. They don't go together because they're not like terms, over a single 4. So this is the exact value of this expression after we figured out that the alpha must have been 30 degrees. All right, so give the homework a try in 5.2 and let me know if you have any questions.